Cloud, and no worries, none of your faces will be in it. I figured out how to remove that, so that's fun. Unless you want your face to be in it, I guess, but I don't want it because it's more information. It's actually easier to not. But, okay. Courses, programming 2. We're going to start, so you have your quiz this weekend / through Tuesday, and then your project due this Sunday. So the project is definitely the priority. Like that is, yeah, 100% the priority. But the quiz is still important. So I'm going to go over the quiz first. And so if any of you are like, I'm good on the project, I don't need help on the project, you never know. I won't judge you if you're working ahead. I'm going to do the quiz study guide first. You could like leave after getting that information if you feel like you're ahead. After that, for the project, I'm going to go over part 2 and 4 conceptually. You don't have to be on part 2 and 4 yet. If you haven't done part 1, you're definitely behind. I highly recommend you already be on part 2, at least, or finish it would be great. But yeah, part 2, but 3 and 4 is what we're going to go over. And then after that, if anyone has any questions about anything, I'll go over it in like more detail, or if like it's really confusing, I can do it, even code some stuff up. But generally for the linked list project, I talk conceptually, and I try to avoid like programming specifics, just because that's on you guys to implement. So as long as you get it conceptually, hopefully you can get it programmatically, but I can still go over that. But without further ado, home, quiz study guide file IO. Here we go. Okay, so this is all just about like if you wanted to have files on your computer that you wanted to get information from. And here I can zoom in. There we go. Okay, so to start us off, what does a full path of a file include? There's 3 components. And you can just, you store it as a string really. There is the directory, the file name, and then the extension. Now, usually extensions actually aren't this long, and I think the max is like 4. But there's the directory, file name, and then the extension. Those are the 3 components of a file path. The directory is saying, where are we actually going to find this file? So we'll talk about absolute and relative file paths later, but in general, this is saying wherever you start looking, because that can be different, and like I said, we'll get to that in a bit. Wherever you start looking, go into this folder, and you can have as many as you want. Directory 2, 3, it's saying go into directory folder, and then into the next folder, and next one. And that's the, once you get to the last slash, that's saying we are now in the folder where I want to be. This is the location. The next is saying what the actual name of the file is going to be. So that's what you see when you're like moving around your files. Like let's go to desktop. It's like all these names here, they have a little icon, and that's based on the extension. But the actual name of it, it's not really zooming in on the names. But the actual name of what we're looking at is the file name. And then last but not least, the extension, that'd be like for a text file, it'd be TXT, PDF, Excel files, I think it's EXXL or something like that. But so that's what the extension is. Those are the 3 components. So all of this is the directory, file name, and then extension. What is a delimiter and what is the purpose does it serve? So a delimiter is something that you say, you put it into your file and you say, this is one chunk of information. So everything before the delimiter is one chunk, everything after is a separate chunk. And you can have multiple delimiters. So the most basic example of that is a CSV file. So what is a CSV file? It stands for comma separated value. That is just the acronym. And the extension for it is also CSV. Excel is really good at reading CSV files. So if I have an example one, I moved it to be in here, didn't I? Yes. So right here, I have a CSV file. If I go to properties and look at it, it says that it's a CSV file right here. So if I open it, we'll double click it, Excel is just going to open it for me. Be like, here you go. I opened it and it loads like this. Well, Excel does some magic to the file because it's in a specific format of comma separated values. If you don't want it to format it properly and want to see what it is, just plain text, you can open it in a text editor. And most people have like Notepad. I'm going to open it with what's called VS Code, but it's just a text editor. Anything that allows you to see what's the text of a file. I can't zoom in, so that's super helpful. Can you kind of see that at least? Yeah, okay. So you can see here, you got a bunch of commas going on. And all those commas, go to here, they correlate to what's going on here. So there's an empty cell, so we got 2 commas. So it's empty, empty. And then this is a value. And then this is a value. So the comma here acts as a delimiter to saying everything between 2 commas or before a comma is a value by itself. And commas separate the values. Technically, also in CSVs, at the very end, a new line character also counts as a delimiter. So we've got a bunch of commas, but then there's no comma at the very end because it just does new line. And so the new line character counts as a delimiter. In most cases, a new line character will be your basic delimiter, but CSV files are another very common format. And so the commas are delimiters here. And that concept will be more useful in a little bit when we go over like how to actually use information from a file and how to get it. There's specific functions that use delimiters to break up the information. Okay, true or false, all file formats are the same? Definitely false. So CSV files and a text file to begin with. Both of them are plain text, like you can open a CSV file and read it and kind of understand what's going on. But CSV files specifically, when you say you're writing a CSV file, that means that the format of what's going on in there will be comma separated values. Like that is a super basic, that is what you're saying the format is. A basic TXT file, a basic text file, you're saying that it's just going to be plain text. Like you should be able to just open it and read it, should be fine. That probably means like there might be some new line characters just to make it more readable or whatever, but it's just plain text. Now, when we get into binary files, this is going to be a little different because binary files, you can't read them like a human. Do I have an example of a binary file somewhere? Might. This might be one. Yes, here we go. Binary file. This does not make sense to you. This is a PowerPoint file. You're not supposed to be able to read it, but there is the file, it's storing bytes of information, and those bytes mean something to whatever opens the binary file. So for a PowerPoint file, the PowerPoint software knows how to read the bytes of the file and go byte by byte and figure out to turn those information into your slides. So you're not supposed to be able to read it with just a text document. Like there's no conversion to that. And with the binary file, you're going to need a specific documentation to tell you how to read it. If you don't have that, then if you mess with bits, it might change some random thing and break something. But so yeah, you're not supposed to be able to just read binary files like this.
Oh, I have a question.
Carrick has a question. What's up?
Are JSON files like compatible with C++? Because I use them in like JavaScript and I like their syntax. Is that like, can you utilize those in C++?
Definitely. So the question was, can JSON files be used in C++ like syntactically? Yes. Now you're probably going to need, if you want to use them as easily as a JavaScript file, because I know in JavaScript there's like functions to do things specifically with JSON stuff. Yeah. So you might need to find a library that works with JSON files specifically to do it as easily. But even then, a JSON file is just a specific way to format information. So you could use the delimiters that are in a JSON file to break up the information, like you could manually make one. But I bet there is a library for that. So there's these, it's not in the standard library. So there wouldn't be like a straightforward thing, but people definitely make their own, so you can take their code. Obviously, you wouldn't do this in any assignment here, but we wouldn't give you an assignment that you couldn't do with like the default stuff. So you could like take their code and then import it or hashtag include it, and then you'd have access to their functions, and that would help you break it up. Yeah, you can open any file with C++. So as long as you can open it and it is structured in any way, you could use it. Okay, so yeah, that's different file formats. What's the difference between a / and a / when it comes to file paths? If you're using Windows, it doesn't matter which one you use. Windows can actually accept both. They prefer backslashes. Like if I went to here, right click, properties, and then oh God, this is so tiny. Here, I know what I can do. You can see that? I guess it is blown up. Sure, fuck it. I can barely read it. I'm blind. So right here on this little thing, it's using backslashes for the directory. So Windows does prefer backslashes, but they can use both. But Unix systems like Linux and Mac operating systems, they require forward slashes. Or that is a requirement. So we're actually going to be doing stuff later that we might have you test on Unix systems, and there's ways to do that through UF, and we'll get to that later. But you'll have to do forward slashes. So some people recommend only using forward slashes, but for Windows, you can technically do either way, and they prefer backslashes, but up to you how that works. And so that's the difference that it's asking. So what's the difference between forward and backslash when it comes to file path? Depends on the operating system. Windows can take both, but it prefers backslash. Unix systems like Linux and Mac require forward slashes.
Aren't backslashes also used as escape characters? And so, like, if you're using, I've done this before where I'm like importing a directory and I copy paste from the file explorer on Windows, and then it thinks the backslashes are escape characters rather than, as part of a plain text string.
Yes, that is true, but that's a really easy thing to fix. So actually we get to escape characters later because of that concept, but here. So if I just copy and paste this and put it into my code. So you'll see that this is mad because all of these backslashes are highlighted in like a yellow. The only one that does something properly is right here, this \t. So both of them are highlighted in yellow. It's because backslash, like you said, Nathan, I think is the one who said it. Nathan said like, oh, you didn't hear that at all. Shit, I'm so sorry. So Nathan commented, with backslashes, aren't those something to do with escape characters? Because when he used it, it gave him issues because it was trying to do something with escape characters here. When he copied and pasted it from like properties here. And so it's correct, they are escape characters. And so you can see their escape characters because it's highlighting, but the only one that's highlighting a character after is this \t, because \t is an escape character for the tab character. So if you wanted to type out tab in your string, you can't just put tab because that does something in code. Like if I try to do tab here, it puts a tab in the code. Oh, I guess I can do that, but that might be space or something. I don't know how it's going to read that. But that's what that was built for. To make it so it works, just every backslash character you see, put another backslash. Because two backslashes together is the escape character for backslash. And so now this string would read as, let's see out. Here we go, run it. Right there. So now there's two backslashes, but that two backslashes is the escape character for a single backslash. So now it puts that there like that. You guys should have covered that in Programming 1, at least a little bit. And I know you should have because I TA for Programming 1 and we definitely covered it. But we're seeing it again and we'll go over it again. Okay. So, so yeah, backslash and forward slashes, yes, and they do escape characters are a concept. We'll cover that. But that's the general file IO stuff. Okay. File IO in practice, like actually using it. What classes can we use to open files for reading and writing? Well, first off, we have to #include fstream. That's in the standard library. It stands for file stream, just like IO stream stands for input output stream, file stream. And then there's three objects we can use. There's ifstream, ofstream, and fstream. And if my IDE will figure itself out, there we go. So if you can tell, ifstream stands for the input file stream, ofstream stands for output file stream, and then fstream could be either. I personally don't use fstream, but that's basically just, that's an object that you can assign to be either an input file stream or an output file stream. So it does have that mix, but ifstream and ofstream are explicit. And I don't, that by saying that, I don't mean you can do this because they're different objects. That would be bad. You can't do that. Fstream can be either in its, like its constructor has a parameter for it being either input or output. And so you could construct a new one that's opposite. Like it doesn't have to be input or output only. Does that make sense? How? I don't use it very often, so we're gonna hope for the best. No, we got this. We can do this, I believe. Come on, autocomplete for me. I don't know. There we go. Okay. So we got the mode. Yeah, finding the file name first. Yeah, file name and then mode. So I think it's so just any file name. Testing.text. And then in, it's something in, it's like base in, that's wrong. IO base in. Ooh, there we go. Okay, let's go confirm that that's correct. Fstream setups. Yeah, because it's you say either in or out, but we're gonna go check that. Yeah, IO space. Okay. Let's see an example. Come on, right? That would need. See, oh no, that's just IF and OF. I really hate. I just don't use fstream. I'm gonna be honest. But let's. There's nothing with just fstream. That's so sad. Okay, that's so great that I can't even find it. Yeah, sorry. But that does here. We can. One way I can prove it is this. I'll make it output, and then either dot write hello 5 either dot close. Yeah, you ran. Proud of you. Testing. Hello. Awesome. Cool. So yeah, just used it as an output properly. So good. And I think if you don't put that, it's actually fine and it just tries its best. Yeah, you don't have to put that, but write is explicitly an output concept. Read would be input. So if we run this, that should actually still work. No, it did not. So there you go. But it didn't crash though. So it's undefined behavior. Yeah, I honestly have no idea what it did. But yeah, iOS base. If it was in, yes, you would be using. So if the question was if it was in, you would just be reading information from a file. Yes. But yeah, out, just making sure. There we go. Yeah, right there. And it exists. Cool. So yeah, just make sure to put the iOS base in for that kind of thing. Cool. Okay. What operators can we use to read and write data to and from a file? So the one that I showed you is actually not what this is talking about. So there are the read and write functions, but the operators it's talking about, let's do input. What did I have? Did I have attendance in here? Yeah. There we go. And then output, we're going to do testing. Text. Cool. To get input from a file, the operator you can use is the, what was that? Greater than? Yeah, the greater than operator. It would be bit shifting to the right, technically, whichever way you think about it. But you use that for cin. We've seen that in the context of cin. And it's the same thing because cin is a stream. Input is a stream. Just one is an input stream. One of them is an input file stream. But they both use in the same way. They read until a space. So if we do this, let's make some string there. We do this there. C out one there. One. So with that, and we run it. So there's some weird characters. I think that happened before too. I don't know where the weird characters come from. I think it's just because the CSV file has some extra stuff that we don't see. But if we go to here, open it, VS Code. So here's the CSV file in plain text. I need to run it again. There we go. So here's the CSV file in plain text versus what we printed out. And what we printed out, I don't know where these weird characters come from. The one I put there, but I don't know where these weird characters came from. For the comma January, that was everything up until a space. So just like cin, how that read till a space, this reads till a space. And then output, same thing. Go to here, do output. And it's not it's the same thing as C out, so it's not the greater than, but the less than. And we do there. Oh, fix my glasses. There we go. And run that. Now, if we go to here and go to testing, or it's cap. Oh, no, that worked. I put capital there, so I guess, was that capital? If I delete it. Now it's capital. There we go. That was weird. Whatever. But so it wrote the same thing. Okay, so that's the operator you can use. And how can you read an entire line from a file? This is what you'd be using for text files to read most of the information. Because while that operator is great, it has limitations where it's just reading till a space. But to get a whole line from a file, we use a function called getLine. So we go to here. I'm going to delete all that. I'm going to keep var. But the function getLine, it's not input.getLine, it's just getLine. And you pass in input, and then you pass in a string variable. So this is the setup right here. And what this is going to do is get line. So it's going to get a line from this stream, so this IF stream, and then store it in this string. So if we do that and then see out there and run it, it gets the whole line from that file until a new line character, which is what's happened when we make a new line. It gets it all that information and prints it out. Yes? We have a question in the audience. What's up? So the question was, what if you want a specific line? Is there a way to specify it? You would just have to iterate through until that line. Like there's no like number. I don't think. Let me can try. If there was a number, it would be like 3. Yeah, no, because that's thinking that's a character, and that's not. Yeah, it doesn't want that. Because it does have a third parameter, but it's not that. So yeah, I think the only way I know is to go through each line. There might be a way that I don't know, but yeah. So yeah, that's how you read a whole line from a file. Now with this same function, what it's doing is using the new line character as a delimiter. So we talked about delimiters, that's where it's saying information is. So it's getting all the stuff before the delimiter and saying that's what we're storing. You can change what it uses as its delimiter by putting another variable here. And so what if we make the variable a comma? We're probably going to actually need to put this in a loop. That would be 10, sure. So we do that and run that. We will see that it's now getting all the information in before and between commas and printing it out. So there's the weird stuff, and then there's a comma, then there was another comma, then there's this and a comma, this comma, like it's getting all that information. And the one key thing to note here, which is super important, it was true for the last one as well, it's not reading the delimiter. So it doesn't actually take in the delimiter. There's no commas here. So it takes everything except the delimiter. So that is really important. Yeah. And I was just putting a new line character at the end of it with endl. That's why it's doing it on a new line. But there's no delimiter. You have to put, yeah, if you want the delimiter, you have to add that back in yourself. Okay. What is a data-driven program? So that's just terminology. You really just got to memorize it. A data-driven program is any program that uses an external file and reads an information from it. So anything that has like a database, anything that has some sort of server where it stores and reads information from, data-driven program. What are the differences between an absolute path and relative paths? So I kind of mentioned that a little bit ago, but I did not go in depth at all. So what I've been using this entire time has been relative paths. So I just type in the name of the file. I don't even have to put a directory. And my program starts its relative paths from this folder right here. So this folder is where it starts looking for stuff. But what if maybe you were a little lazy or you didn't want to have to deal with relative paths just yet? And some programs actually, since when you set up the program, you tell it where to install things. And so that one, it's setting the absolute file path actually. But an absolute file path, instead of starting from nothing, it starts with a letter and a colon. And it's referencing one of your drives on your computer. So all computers have drives.
That's only
And-
Windows, right? 'Cause
No,
I know Linux does not have that. They don't have the C colon.
Well,
That's
they have
not-
something. Linux absolute path.
I think it's just, yeah, it just starts from like the lowest you want to go.
But there's
yeah,
always a working directory. And so that's one where, like, wherever your make file, wherever your program starts running from. If you wanted to start from the home one, don't you do like 3 dots or something?
well, that's just a shortcut, but you don't have to do that. Because that's just because you can do
Oh, to start an absolute path in Linux, you put a slash at the beginning.
well, oh, okay, yeah.
Is that true?
Yeah, no, but I just meant there's no like C colon, like there's nothing where you're specifying any driver.
Oh, okay. Gotcha. Okay, yeah, that's definitely my just experience with Windows slipping in. Okay, gotcha. Okay, so for Windows, it starts from a C drive, from any drive that you have. But it looks like for Linux and Unity. Oh, his question, by the way. definitely. I'm so off today. Question was like, is the C drive isn't a thing in Linux or Mac environments? And it turns out that's true, definitely. But there's still a distinction for absolute and relative paths, and so that's with a singular forward slash like this. And so you put that, and that one's saying absolute path. Start it from the beginning of the whatever their root is. They don't have. Yeah, relative, you don't start it with that. That also could be wrong. I don't have a Linux or Mac machine, so I really don't know.
As far as I know, that's right. But
We have a question in the audience. I honestly don't know. I don't think he would do that kind of thing, knowing him. I don't. So the question was, will he test us on like Mac, Windows, Linux stuff?
yeah.
I don't think he would. Since he asked about the forward and backslash, and the difference is Windows and Mac, like that is the difference. He will probably test you on that. Like I think the big thing is whatever he covers in his slides. Like honestly, even the study guide stuff. If we go to his slides that he uses for his lecture. Further. I probably could have just searched. Yeah. So since this one, it talks about Linux and Mac and Windows, that one you probably will get tested on. But let me look if it says it anywhere else. Yeah, I know. It's just there. What does he talk about with the relative? I'm just going to Google it. Absolute. So even him, his all is just in Windows. So the testing would probably be Windows. Sorry for all of you Mac or Linux users. But as always, if you get a question on a test, put what you think is the right answer. If you can argue it later, then that works. Now, I've also had people that put what they thought was the right answer and they were prepared to argue it, but then they were wrong. Like we can debate it. But this semester, there's actually been some stuff that carried over from last semester. I'm like, I thought we had caught it, and then it's like, oh crap, we gotta give them points back. So we will like just put what you think is the right answer if you disagree. But in general, it looks like we're probably gonna be Windows specific.
Boo.
Boo. Yeah, boo. You'll live. Imagine not using a Windows computer. Okay. Absolute relative. Where is a program look for files by default? That's the working directory. So the working directory, it's different for every like IDE or program, but really, if you're not working in an IDE, it's wherever your program starts its execution from. So when we get to make files, it's that, but it's wherever your program starts working from. In an IDE, it's usually wherever your source code is. Like for me, I've been using relative paths and they've been ending up here. But I know in Mac, it's in like the CMake debug folder or something like that. It's one, you'll figure it out. But in practical usage, if you want to know where it is, like 100%, I've never had this fail. With 3 lines of code doing an output file stream and then some file name, no relative path, like no directory, just that. And then do output write hello 5, and then output.close to make sure it closes. I had one student where that was an issue. So I now always just add that on. Like delete testing. If we run that, So it made the file right here. So that's how you know where your relative file path starts for your IDE specifically. That's the method that I always use.
I have a question.
Carrick has a question. What's up?
What is the second parameter of that output.write?
So we haven't been using read and write because it's mainly used for binary stuff. But what the first one is obviously the string. It actually has to be a character pointer. But then this one is how many bytes of information I want to write from this pointer.
Okay.
So for 5, hello is 5 characters long. So I'm saying all 5 of them, but you could put like 3.
And if you put 3, would it just do HEL?
Yep. So the question was, what does the second parameter do in this write right here? And the first one dictates how many bytes you write of this. And so each character is 1 byte. So 3 would be HEL. 5 is the whole thing. I wonder what happens when I put like 7. I bet it's going to be mad at me. We can find out. Oh, yeah, it has no fucking clue what's going on for those last 2. So it probably isn't yelling at me just because I'm not changing them at all. If I was reading, it might actually yell at me because it's like, you're trying to overwrite stuff that you are not authorized to write. But with reading, it probably just goes to those next addresses and reads them. Okay. So that's good. Cool. Making me yawn, Carrick.
My bad.
So yeah, and that's just where does the program look for files by default? It's wherever it starts running from. And then where does an IDE look for files by default? It's usually where your source code is. I'm fairly certain that's true. But I know you can change it because I've had some students where they like accidentally put it in some random freaking place. And so we literally had to write this code and then Control F for this file name through their whole operating system to find out where it went. So some IDEs, you can mess that up. Okay, cool. Last but not least, what is an escape sequence? So we talked about that a little ago. Thank you, Nathan. But we're gonna just look it up. So it's escape characters, C++. I guess it is called escape sequences, C, but like that, it's not even escape characters anymore. But they're all right here. I guess there's some weird ones on there. But basically, they're just all the characters that you wouldn't always be able to put into a string, even if you wanted to. So like for single or double quotes, those things represent the beginning or end of a character. So there's no way that if you wanted to have just the single quote character, you couldn't do that because you can't do char A equals. It's not, oh my gosh, this isn't, there we go. So like that isn't a thing. That's not a concept you can do. But with the escape characters, you now just add a little doop. There it goes. I am on insert, aren't I? There. So now this A is representing a single quote character. And then same thing for strings with double quotes. If you wanted it to instead be hello inside quotes as the string itself, you can't put those quotes there because now it thinks it's dealing with a string and then a random thing and then another string. But instead, you put a backslash there and a backslash there. And so it's start of a string, escape character for a double quote, more string, escape character for a double quote, and then end of string. So that's what that helps with. And what you have access to, single, double quote, question mark, backslash, those you should know. Definitely know those. You should also know new line and tab and backspace. The reason why I say you should know those is because I think those are the ones that are most used. And they're also for new line, backspace, and tab. It's the escape character is the first letter of it. So if you're like, what's the escape character for tab? It's T, because it's tab. Obviously, going from escape character T to tab itself, you might have to think a little bit, but you should know that. And then same with backspace and new line. New line, definitely. And then the reason why I say you should know single, double quote, question mark, and backslash is because they are literally themselves So if you're like, how do I get a question mark escape sequence? It's using a question mark. So that's why you should know those. The audible bell, the backspace, form feed, carriage return, vertical tab, those are definitely more niche. I've never seen them used ever. But there you go. Okay, so that's all of the study guide. Any questions about anything we covered over all of that? I can back up if I said I was going to cover something later and I never got to it. Cool. Okay. So next, we're going to go over the project, specifically parts of part 3 and 4. Let's go to SciBooks, sign in. Let's close this out. Projects, part 3. Okay. So for part 3, you've got these 4 new things: insert before, insert after, and insert at. Insert before and insert after are a little unique in that they actually aren't relative to your linked list itself. They could honestly be static functions if you really felt like it. Let's go to assignment, linked list. PDF. Here we go. So yeah, insert before and insert after. It's given a pointer to a node, create a new node to store the passed in value after the indicated node. And then same thing with insert before, but except it's before. So if you go look at the signature, insert before and insert after, they take in a node and they take in data, and you have to put a new node either before or after that one. So yeah, they're unique in that you really aren't working with your linked list at all. So to implement that, the 2 things you're given is just a node. You don't know what's to the right or to the left. And then you're given some sort of data. So what you can do is just make a new node. It's got data, starts off pointing to null pointers. And so for insert before, you would need to set the, use red, sure. Set the before of this to this question mark. So set the after of this to this node itself. And then set the before of this node to the new node we made. And so that gets rid of that. And then, yes, there. And now everything's set up properly. So an easier look at this. Move that up. Is now we've got an unknown pointer to it, D, and then a double link to this empty one here, and then an unknown. Yeah, single, double, yes. This is what we end up with. And so we do not need to know what's the left or to the right, what those question marks are to do this properly. They could be null. They could be another node. Either way, this gets set up properly. I guess technically you could check to make sure the passed in node isn't null pointer, because they could just pass in null pointer, but they don't say that in the lab docs. So I wouldn't even make that check, because they would probably have to say like throw something if you did that. Yeah, they don't say anything about throwing an error in there at all. So I wouldn't even worry about that unless like you think you need to because of a test case. Okay, so after making that, I would then say insert at, you should utilize these. So if they say insert at an index, then you can use either before or after and go to that index. So like either go either go to that index currently and do insert before, or go to one less and do insert after. And then with the extra stipulation, so here we go. So let's clear all this. It's like, let's say your linked list was do with the tail and a head. If they say insert at 1, that means you need to insert it right there because it's 0, 1. So that means you could either do this one or this one and do insert after or insert before. Both those would work. That makes sense? And then same with 2. You just go right there. And then 3 and 4 are different because with 3 and 4, you can't have that because you couldn't do either the before or after. And since you can't do before or after, it's a little unique. Let's say insert at 0 or insert at size. I want you guys to think about, like, if it's getting inserted there, you're adding a node here or you're adding a node here. What function do you have that adds nodes in those places? Oh my God, Carrick, you look very comfy. Okay. But so yeah, if you add a node here, add a node here, you have functions that do that for you. So Victoria said, oh, the ones we did in part 1? Yes. So you could have a check to see if it's this one or if it's this one. And if it's neither of those and it's not out of bounds, then you can do insert after or before, which we showed how easy that was. So insert just a couple of if statements, do some checks. You shouldn't have to write any really, you already have all the logic for it. So a lot of this project, because of how redundant it is, you really got to look out for places that you've already written the code for so you don't write it again. Spoiler alert, if you haven't caught on, it's add head and add tail, respectively, for those two. Spoilers. Okay.
Is there any way I can ask like a very tiny question on part 2 of this project? It's only on one of the functions, and it's just like annoying me.
Carrick is making a very nice request to ask something about part 2, and usually I would finish part 4 before going back to part 2 for any questions, but I will go back to part 2 for one question from Carrick and then one from you because it sounds. Or are there multiple questions for part 2? Do you have questions about part 2? Do you have questions about part 2 for later? Here, Carrick.
Oh, my question is only a syntactical one, like not a conceptual or anything.
Okay, fine, sure. We're gonna.
We can go back to it after 4.
Nah, what is it? What's up?
I'm just so whenever I'm trying to write my copy assignment operator, but it's just like underlining whenever I try to like I just can't get the syntax correct.
What's your actual question? What is it underlining?
I think it's underlining the ampersand. Let me see.
Oh, for creating the prototype for it, like the actual, not any code inside of it, but creating the.
Not the code. It like I just can't get like the assignment operator itself to.
Okay.
It's
So
underlining. Oh yeah, so yeah, it's underlining the ampersand, and then it's saying, and then it's not letting me access like any of my class variables or my nested node class or anything. So it's just underlining everything when I try to. It like, yeah.
So your constructor, copy constructor, you said. So it looks something.
Copy assignment operator.
Copy assignment operator. Okay, so it looks something like linked. And the class definition, it looks like linked lists. Or do you return a reference like that? And I can actually probably just copy it from this book, can't I?
Yeah.
We're talking about the assignment operator. He's having issues with syntax of it. So it's this, yeah.
Yeah, right, that one right there.
So linked list T ampersand operator equals const linked list. I think there's going to be another T ampersand, yeah. T ampersand RHS. So you've got that in here, and that's fine, right?
Yes, that's fine.
It's just moving it outside.
Yeah.
Okay.
It's
So
getting-
with this, first thing definitely need is a template.
yeah, have that.
Okay, and then next, this right here needs a scope resolution operator,
Did that.
and it's T specifically. And this is mad because, oh, no, that's not mad. That's it right there. Yeah, it's an easy one. What's different?
Oh, I did that, and then like it was underlining the linked list, like the first one, and it said I needed a type name before that. And then when I put the type name before that, it underlined the ampersand. Okay, wait, let me see what I have here. Okay, the linked list.
Victoria, I'll take one of your questions too, if you'd like, about part 2. You don't have Victoria.
I mean, it's just like my brain is
Oh,
Uh,
let me try to
all right. Yeah, that was that. Thank you so much.
here. Well, you can. Is anyone here wants to see part 4 stuff? Say it in the chat.
Sure. I don't mind.
Or
I
would
mean,
you rather have part 2 questions?
that was my only question. I just was curious.
Okay. You're getting over. Yeah, we're gonna go over part 4 first, then you can take some time to come over with. Yeah. Okay, share screen. Part 4. Okay, did I go over all of part 1? So the insert app before, yes. Ooh, equality operator. So for the equality operator, they have to. So it's not that you don't want to say like the pointers are equal, because obviously if you only have one linked list and you grab 2 different pointers, if you have 2 different objects that are the same thing that like store the same point. I don't know how you'd even get to that point. But the goal is that if you have 2 linked lists, let me just undo that. Yes. Even if they're set up like differently in memory, if they have the same values, these 2 would be the same linked list, right? I didn't say where head and tail were, but I'm assuming you can like visualize that. But yes, these 2 are the same linked list, right? With the equality operator. So the first easy check is if one of them has an extra element, even if it's the same 1, 2, 3, 4, if one of them has an extra, they're different. So a good first check is node count. And next, if node count is the same and you trust the rest of your code, you should be able to loop through them, both of them, loop through either the left side operators node count or the right. So this object's the passed in one's node count, and check just the data in each node. And if they're the same, then yes. If they're the same, then yes, same, yes, same, yes. And then if any one of them is not the same, you just return false. But if they are all true and you get through all the checks, then you just return true. So that one's a pretty straightforward one. It just goes into, as long as you know how to loop through one linked list, you're good there. Okay. So that's part 3. Okay, part 4. So this is where we get into like all the remove stuff. It's like we want to get rid of elements, and this can get a little bit weird. So remove head and remove tail, those ones are say straightforward. But those ones are a little easier. Just gonna show one. All. We got a head, tail, doubly linked, ends point to null. Removing head should really be as simple as shifting it to point to this thing, deleting the previous thing, erase that, and then setting this explicitly to null. So like that, there shouldn't be any ifs, ands, or buts there. That should be really straightforward. Yes. The only potentially weird part is, so that's if, what is the condition for this? That's if head has a next. So if head doesn't have a next, this doesn't work. Because if head next,
That just means there's one element in your.
yeah.
Okay.
So yeah, another check for that kind of thing. If node count is equal to 1. So if head and tail are pointing to the same thing, or if node count equal to 1, or if head next is null, then you don't move head to not next. So there is a check there. So the check would be like, check that. If that's true, then just delete head and set head and tail both to null pointers. So that is a unique concept. Okay. But so however you want to set that up, make sure you do your checks right with that. I think those are the only two cases, because the other one that you usually check in this kind of situation would be if 2 elements, and then here you can set head to the next and then delete that and then set to null and you're good. Yeah, so you only need those 2 checks. Tail obviously is similar, but the opposite. Remove at, I'm fairly certain that one takes in a address and you go, or index. Yeah, it deletes an index node from a list. So same thing as insert at and remove at. Let's clear all, head, tail, doubly linked. No. If they say remove at 0 or remove at size -1, that's this one or this one. And in both those cases, you have to deal with that head and tail pointer. So you might, instead of like doing a custom algorithm for removing something in the middle, just call remove head, remove tail. Like remove head, remove tail, insert head, insert tail, or add head, add tail. Both of those are for the edge cases of dealing with the head and the tail. That's what those are useful for. It'd be the equivalent of insert at 0 or insert at size. So just get the head and tail done, so you can just call it once inside insert at. But then anywhere in the middle, it's a lot easier. But there's one syntactical thing that's a little wonky. So get all that, move it up. I didn't grab the end, but that's okay. I'll just erase it. Okay, so if it said remove at 1, it's removing this one. You don't just delete it, because you have to move around the pointer. So the pointer, let's get rid of that. So that's there. And there's a next there, a previous there, a next there, a previous there. So to remove it, the first things you got to do is move around the adjacent nodes pointers. So you have to get this one to point to here, and this one to point to here for the next and previous respectively. So getting rid of those. How you would do that is depending on what you're pointing to, but I personally would start with creating like a current pointer. and start at head and then move down to the index so it ends up pointing to here. And with current, you can say current, next, previous equals current, previous. Getting really tiny there. But you say current next previous equals current previous. So what this is saying here is currents next previous pointer, make that specifically point to current previous. So it's going to assign this guy's previous pointer to here, which is what we want. And then just kind of the opposite for current previous next equals current next. So that's like a little weird of like a jumping around pointers, but does that make sense? Current, because you got current, and then it's kind of like file pass. Like the first, everything before the last thing is saying go to this file and then this file, but then this is where we actually want to deal with. So we're at the current file, go to the next, and then we're dealing with the previous of this node. And you're saying the previous of that node equals current previous. So that's right here. What function? Oh, this was for the remove at function. Yeah. So then once you do that for both of them, you get to what we wanted. Oh, deleted, got rid of too much. And so then once you have that set up, all you got to do is delete current. Because once you do that, that's all gone. That's your setup, and that's a doubly linked list. So they're pointing to each other. You're shaking your head and no.
No, I'm looking back and forth. Okay, so wait, what I'm trying to gather is so you remove current, but then like you reset the pointers to each other, like the nodes that are outside of current. So then, okay, yeah, I get it.
Victoria, we're just walking through like the thought process, trying to process it. But anyone else need to just like talk through it for a second?
Nope. I'm good.
Okay. So cool. So that is the remove at.
I have like an unrelated question.
Unrelated question. What's up?
What's the temperature in Gainesville right now? Because I have to leave to go to my class in a bit.
What's the temperature in Gainesville is the unrelated question. You're lucky.
Wait, you see no in Gainesville?
He's in his house and he needs to leave and he doesn't want to go check the temperature outside. He's being very lazy.
Oh,
Why did you type Gainesville?
Because I'm tired. Okay.
Oh.
It's 71 degrees.
Ooh, okay.
Yeah, it's nice outside.
yeah, it's nice.
Okay. So yeah, let's remove head. So remove head, remove tail, remove at, and then remove. Remove takes in a data. Where's remove?
It's down. Down. There you go.
Clear is remove everything. Remove takes in a singular data, and you have to remove every node that has that data stored in it. And so for that kind of thing, I highly recommend an algorithm that goes through, I'm saying the word algorithm, that goes through every index of your linked list. And if it finds something of that data, just call the remove at function. So it knows what index it's at. And if it finds a node, then it just removes at that index. Yes, Victoria? Okay. You got a linked list, head, tail, doubly linked. If you say you need to remove all instances of 7, Then you just have some sort of iterator. So it's there. It's like, I'm at index 0. Nothing's there. Go here. I'm at index 1. Oh, I found something. Remove at index 1. And so it calls your remove at function, which we just walked over, does all the stuff. Decrease the index that you're at because it does, you need to do that. So now it goes to here. That's the new index 1. You're fine. Go to here because this is gone and it's shifted. And you're not here. Index 2, remove that. Does that make sense? Okay, something in the chat. What's the difference between clear and the destructor? They're actually, you can call clear in the destructor. Same thing. So yeah, you can call clear the destructor. You can't call the destructor in clear. That's not how the destructor, because clear gets rid of all the nodes and sets things to null pointer, but technically that object can still be used again. Question was, is it fine if I already wrote the clear function in part 1? Yeah, that's fine. Yeah, so clear and the destructor are very similar. The destructor is just called at a specific point in time. You can't manually call that, but you could call clear in the destructor. Okay. Copy assignment, copy operator, and the assignment operator. Those ones, I would highly recommend using either your add head or add tail function, because you have your. So if we clear it all, you have your original linked list to copy from. Add tail, sure. And so just create a pointer, call it current, love the word current. Points to there. And then on your this object, if you're starting at tail, add head. And then pass in current data. And you just keep cycling current down the length. And then the opposite if you want to start at head and go to tail. You do add tail instead of add head. Okay. And the assignment operator, yeah, because they're functionally they do the same thing, just returning. And for the assignment operator, you have to clear it first.
Can't I just like an operator equal? Can't I just like call copy constructor and clear, or like clear and then put copy constructor?
Sure. No,
No.
because you have to change the this object. And so maybe if you did this equals with the no, yeah, no, because this is already yeah, no.
So I can call clear.
You can call clear,
So write this. Okay.
and then you just copy that. There might be a way that you could call the copy instructor in the assignment operator, but I don't think so.
I'm just trying to see if there's anything.
You'll be fine. And then recursive prints, print forward, print reverse, recursive. Those ones, they take in a node and you keep going until you find a null pointer. So you guys have done recursion before. The end condition is when node equals null pointer. And so at that point you just return, but else you print data and then call it on the either next or previous, the same function recursively. So those are pretty straightforward. Okay. Any questions on part 4? Nathan, Alec, Victoria, Carrick. Carrick, you're getting dressed, so yeah, I don't know how much you've been paying attention.
I'm here. I'm good.
Okay. If there's no questions on that, at this point we are done. I am here if you have any other questions about the linked list project or honestly the quiz or anything really. But I'll leave it open to any questions about like previous stuff, not just what we've covered. Because it is due this Sunday, so you gotta get it done.
Great.
I know it's so much fun.
Hmm.